What's up, scholars? Today we're talking about conditional statements, and we are guest starring my B2 class. Let's give it up, B2! Yes. Very nice. So glad to have you. All right, let's get right into it. A conditional statement is a statement that has two parts, a hypothesis and a conclusion. A hypothesis and a conclusion. All right, a conditional statement can be written in if-then form. The hypothesis is the part P of the conditional statement following the word if. Hypothesis. Which means the conclusion is going to be the part that we abbreviate Q of a conditional statement that follows the word then. Conclusion. By phrasing a conjecture as an if-then statement, we can quickly identify its parts. So we've got the statement, if it is noon in Georgia, then it is 9 a.m. in California. All right, B2. What is the hypothesis if it's the stuff that comes after the word if? It is noon in Georgia. Nicely done, B2. That's right. That's our hypothesis. And B2, what letter do we use to abbreviate the hypothesis? P. Nicely done. All right, B2, what's the conclusion if it comes after the word then? Nicely done, B2. And B2, what letter do we use? Q. Oh my gosh. Bunch of geniuses up in here. That's right. So let's consider the following example. Let P, our hypothesis, be that John attends Heron High School. Boo. Q, the conclusion. Q, the conclusion. John attends an Indianapolis Classical School. So go ahead and cross off the D there, because that's not grammatically correct. We're going to identify and define the four main types of conditional statements, so the four main if-then statements we can make. Note, we're going to use the symbol tilde. It's a tilde, and that'll represent the negated version of the statement. So, for example, this tilde P, which we'll actually read as not P, will be the negated version or the negative version. So, not P in our original hypothesis would be John does not attend Heron High School. John does not attend Heron High School. So we just take our original statement and make it negative. Okay, cool. We've got these four types of conditional statements, or four types of if-then statements that we can make. Our original conditional, we'll write it out in symbols. It'll be if P, then Q. So P and then the arrow Q. If P, then Q. That's our conditional statement. Writing it out, we would say, if John attends Heron High School, then John attends an Indianapolis Classical School. So if P, if John attends Heron High School, then John attends an Indianapolis Classical School. That's our original conditional statement, if then. If John attends Heron High School, then John attends an Indianapolis Classical School. All right, B2, that came out funny. B2, is that a true statement that if John attends Heron High School, then John attends an Indianapolis Classical School? Yes, that's true. Very good. All right, the converse statement, we're going to take our hypothesis and conclusion and switch them around. So we'll say, if Q, then P. So instead of starting out with, if John attends Heron High School, we're going to start out with, if John attends an Indianapolis Classical School. If John attends an Indianapolis Classical School, then John attends Heron High School. That's our converse statement where we flip the hypothesis and conclusion. All right, B2, is that a true statement that if John attends an Indianapolis Classical School, John attends Heron High School? No, why not? Where could John be going? Oh, yeah. John could be going to Riverside instead. All right, our inverse statement, we take the original conditional and we make both of them negative. So that'll be if not P, then not Q. So we're going to say, if John does not attend Heron High School, then John does not attend an Indianapolis Classical School. If John does not attend Heron High School, then John does not attend an Indianapolis Classical School. That's our inverse statement where we make both parts of the original conditional negative. All right, B2, is that true? If John doesn't go to Heron, then John doesn't go to an Indianapolis Classical School? No, why not? Again, John could be going to Riverside, which is an Indianapolis Classical School, so that's not true either. And finally, our contrapositive means we're taking our original conditional, flipping it around, and making both parts negative. So this will be if not Q, then not P. So we're going to say, if John does not attend an Indianapolis Classical School, then John does not attend Heron. If John does not attend an Indianapolis Classical School, then John does not attend Heron High School. That's our contrapositive. We flipped it and reversed it, Missy Elliott style. All right, B2, is that a true statement? If John does not attend an Indianapolis Classical School, then John does not attend Heron High School. That is correct. Poor John, not getting to go to any of the Indianapolis Classical Schools. All right, what do we notice about our truth tables? We've got two that are the same and two that are also the same. Who is the same as the conditional? Contrapositive. Good. That will always be true. Whatever the conditional is, if it's true, the contrapositive will be true. If the conditional was false, the contrapositive will also be false. And same thing with the converse and inverse. Those will have the same truth value. It could be the situation that everybody's true. Could be the situation that everybody's false. But these top and bottom will always be the same truth value, and the middle two will also be the same truth value. All right, you guys are doing great. Let's keep cruising. So speaking of true and false, conditional statements can either be true or they can be false. A statement is only false when the hypothesis is true and the conclusion is false. When the hypothesis is true and the conclusion is false. To show that a conditional statement is true, you must present an argument for the conclusion, you must present an argument that the conclusion follows for you must present an argument that the conclusion follows for a, what do I want to say here? Actually, I don't like that sentence at all. Let's just go ahead and cross it off. It's not helpful. To show that a conditional statement is false, describe a single counter example that shows the statement is not always true. Counter example. So a counter example is one example that shows that something is false. All right, example, write a counter example to show that the conditional statement is always false. This says, if x squared equals 16, then x equals 4. First of all, B2, what is the hypothesis? Good job, that's our hypothesis. And what letter are we using to abbreviate that? P. B2, what's my conclusion? And what letter do we use for that? Nice. Okay. So if x squared equals 16, then x has to equal 4. So we can tell by this example that that's not always true. Do any of my genius B2 scholars know what other number that we could square and get 16 that is not 4? Let me give you a hint. Negative 2 squared is positive 4. What's negative 4 squared? Positive 16, yes. Positive 16. So x could equal negative 4. This is our counter example. That's our counter example. It's a statement that proves that that conclusion is false. So if x squared equals 16, x does not have to equal 4. It could have equaled negative 4. This kind of problem will show up a bunch, like on your next test, which won't be for a while, but this kind of problem will be on there for sure. All right, when two statements are both true or both false, they're called equivalent statements. Equivalent statements. Okay, a conditional statement, you guys are going to flip back to your front table. The conditional statement was equivalent to what? Because it had the same truth value. Contrapositive. Conditional is equivalent to its contrapositive. Remember, both of those were true. And from your truth table on the other side, what other two statements were also the same value? Converse and inverse. Very good. Converse and inverse. This will always be true. The conditional and the contrapositive will have the same truth value, and the converse and inverse will always have the same truth value. All right. Example number 1. Write a conditional statement based on the sentence below. Additionally, fill in the table and write the converse, inverse, and positive. After writing these statements, evaluate whether the statements are true or false. Are you guys impressed with how fast I read that sentence? Yeah. All right. People who are millionaires have over $1 million. Okay, we got to make that into an if-then statement. I like that. If you have $1 million, then you are a millionaire. So let's say, right above this, if you have $1 million, then you are a millionaire. What a life. What a life. All right, Genius B2s, what's the hypothesis of our new statement? Very good. You have $1 million. You have $1 million. What's our conclusion then? You're a millionaire. Okay. We're going to pause here, and you're going to fill this in yourself. Dun, 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 dun. All right, now that we've filled out our table, let's decide whether these statements are true or false. B2, if you have over $1 million, are you a millionaire? Yes, you are. That's true. B2, if you're a millionaire, then do you have over $1 million? Yes. B2, if you're not a millionaire, then do you not have over $1 million? Yeah, that's true. And if you are not a millionaire, then you do not have over $1 million. Is that true? Did I write that backwards? Ooh, which one of these did I write backwards? The last one's good, because that's my conclusion. If you are not a millionaire, then you do not have over $1 million. Which one did I write backwards? The inverse, this should have been, if you do not have over $1 million, then you are not a millionaire. If you do not have over $1 million, then you are not a millionaire. If you do not have over 1 milli, then you are not a millionaire. Good eyes, everybody. Okay, cool. To the back. We're going to do these real quick together, and then you are going to do part 2 for your homework. Okay. Thinking back to early geometry stuff, way back when. Postulate number 5, through any 2 points exists exactly one line. Through any 2 points exists exactly one line. And the opposite of that, a line contains at least 2 points. If 2 lines intersect, their intersection is exactly 1 point. Through any 3 points, there exists exactly 1 plane. And the opposite of that, a plane contains at least 3 points. If 2 points lie in a plane, then a line containing those points also lies in that same plane. And if two planes intersect, their intersection is a line. Good job, B2. Give yourselves a hand. Yeah, that's right. All right, love you, scholars. See you soon.